for that, just that alone. Planning is done from the outside in. The family is not even thought of in most circumstances. So in other words, we start with a boundary and we do offset commands and we build the plat. We have no regards to what's happening inside the unit. We don't care. We have the engineers want a pad size. That's all they care about. Square. How many, how's the pad fit? So we have this outside in, the streets and the plat and the lot lines come first in attitude. But it doesn't have the ability, CAD doesn't have the ability to run the numbers. Not easily. So they don't. You can't run the environmental and the cost impacts. So that's happened somewhere when the project starts to get built. Now you know the real cost. That should be at the initial planning stages. We have to run those numbers before the client ever sees that plan. And we can do that with the technology. So we want to take and re-teach the world. So the planning process would be, we took care of number one by looking at the architecture. Say, hey, that's not going to work. Let's fix it. And sometimes that's collaborative. Hopefully that's a collaborative effort. Number two is actually doing the walk. Design the walk. In this case, it could be the next units. The thing could be laying out the units. In this case, design the street system and see if it flows. Use the methods that will make it easy to walk around and say, for example, that walk that crosses the street at one ways. So we don't get run over by a car because we didn't look correctly. So there's a lot of little elements in here I'm not teaching you. Place the buildings as if you're inside the units. That way you can create the open spaces, create the minor walks into the major walks. The minor accesses, they come later. And then in this case we had commercial. How does that tie and blend in with the residential neighborhood? Look at the numbers. Hey, did we do a good job? If we didn't, don't give it to the client. It's not ready to be shown to anybody. We've got to run those numbers. And that's not being done today because you cannot do that in CAD. Well, you can't do it conveniently. The very last thing comes the plat. Not the first thing, the very last thing. Because if we've done everything right, that is going to meet or exceed every ordinance minimum. If we've done everything right. And that way, the families come first. We are building for one reason, for human beings, for us. And as long as those come first, we're going to plan better. And now I want to talk about, I'll have Gary talk about technology. Because in order to move forward, we needed to create a new era. And so he's just going to talk briefly on that.
Good evening again, everyone. My name is Gary Courtney. I work with Rick Harrison on the development, the implementation of the software system that you're seeing highlighted this evening called Performance Planning System. Rick did a great job of highlighting the first component of what we call the Performance Planning System, which is the education, and highlighting some of those concepts that are highlighted in this book here, Prefurbia. Okay, he went over just a few, again, the 8 concepts that you saw there. What I'm going to do briefly is highlight the technology that's used to execute those concepts, again, that we call the Performance Planning System. This is a typical screenshot of AutoCAD. And there's a few things that I want to point out about the screenshot for AutoCAD. And that's the very difficult command lines, the multiple pull-downs that you have, the line colors, the line weights that all represent multiple layers. It's a lot of eye and hand movement. It's a lot of tracking of the multiple layers. It's very cumbersome for the end user. What this is a screenshot of the Performance Planning System. What we get a lot of times when we highlight or when we show the software to individuals that it's extremely simple. It can't possibly do everything that you tout that it does. That's by design. It's by intent to be very simple, to eliminate a lot of the eye and hand coordination that's required in using AutoCAD. It's very simple, multicolor outputs that you see there. Eye and hand movements become very easy. And then there's no commands. You don't have to stroke in any short keys, just very concise prompts that you see there on the screen. This is the same plan that you just saw previously, and what I want to point out about this plan is that, again, it's precise geometry. So everything that you see there is a shape. The lines aren't polylines. They're actual shapes that have qualities to them that you can actually click on and get information about those. It's what's called DTM data. All the colors and the textures here, again, are shapes. So there's no lines that you see on this image or on this graphic here. There's no lines that are used in PPS. Everything is precise technology. And Rick highlighted what's called a chart. We call that the green button or the green feature, which I'll show here momentarily. That's all embedded in the PPS software. And that's where the sustainability measure and factors come into play, where you can actually click a button and get a readout on the impervious or non-impervious surface on any given plot or any given drawing that you see. The shapes also have heights. They can be given heights, rather. They can be given textures that we can then import into what we call virtual reality. That same plan that you just saw is modeled here in what's called a virtual reality or a 3D format, allowing you to navigate through the site freely using a game controller, which we'll show momentarily here. You can also use the keypad. But again, we want to show the simplicity of the software and its capabilities that you can use in a real-time fashion. This doesn't have to be an end result that you can use that costs thousands of dollars to wow the client. This is something that can be incorporated into the collaboration that was spoken to earlier that you can use as an actual design tool. Did I create enough viewpoints? Did I create enough spacing between the different units that you have on a given parcel? And again, it's all effortless. Okay? PPS also is complementary to other softwares as well. GIS data can be imported into the PPS system. You can convert it the same way to create the virtual reality concepts that you see there as well. So again, emphasizing the communication and the use of the virtual reality as a tool for that communication. It's used as part of the design effort. Again, not as a final product that you have here. And up to this point, we've been talking about purely residential, residential planning, residential design. It also can be used for governmental work, commercial work as well, as you see in that previous screenshot there. Now, what I want to quickly do here is give you what we call a plat check scenario to show you the precision that's embedded in the PPS software. So what we did here is we issued a plan that was created in PPS to an engineer. The engineer took that plan using the most common software that's used in the market today, AutoCAD, and made a few minor changes, and then we received that plan back. And this was the plan that we received. At first shot, looks pretty good. It was actually signed off by the surveyor. This was issued for submittal and approved by the city. But when we start to look closer at the plat and convert it back to our PPS system, we see a number of problems that were created simply by the minimal changes that the engineer undertook in the AutoCAD system. Setbacks are off. We have easements and encroachments of the spaces and the properties on the setbacks. Multiple problems due to the construct of the AutoCAD software and system. And then one of the most glaring problems or gross problems here is that a lot's actually off by 1,000 square feet. Okay? That's a huge problem. That's a significant problem, okay, across the board that will not exist when you're using precise geometry, which is part of the PPS system. Again, the drawing is the real data, is the real geometry, and it's accurate to the 20th decimal point, actually. Another quick example here that I want to share with you guys is the two plots that we simply put off the internet to, again, do a spot check to verify the accuracy of each of those plans. And if we look closely at the plan that's on the left side there, we took that plan and we converted it into our PPS system. We just started with the boundary system that you see here. And then we imported the property actually onto the site. And then we begin to verify the offsets that you see demonstrated on the plot here. The plan calls off that offset to be 13 feet from that side lot. When we actually import in PPS, snap the lines, it's actually 15.66 feet. Likewise, the front setback plan shows 29.7 feet as a setback, and it's actually 24 feet. And this is happening, this is what engineers, and this is what's being submitted to the cities, and this is what's being used repetitively over and over, and it's wrong. And it doesn't have to be used, and it doesn't have to be a compounded problem that's wrong, because it's costing dollars. Also part of the PPS software, once you, again, click on a given image That image is a shape, and it has data that's associated with it. When we click on the slot, we can get an immediate readout of the acreage, the square footage, and the other qualities of that lot. We can also do what's called an environmental density check by click of a button, and it gives us this pie chart that you see here that gives us the ratio of impervious surfaces and gives us our other calculations on surfaces on the site as well. And this is, again, embedded in the software. This is not an add-on package, ladies and gentlemen, to the software. This is part of the system that we share. And again, while we're at it, why don't we go ahead and throw this same lot into a virtual reality 3D model as well. Now, taking just, again, these basic plots off the internet, running through this entire exercise took about 10, 15 minutes of effort in the PPS system, okay? Giving you a complete, comprehensive ability to read and understand that site. And when we talk about the communication efforts, we talk about the technology that's embedded in the PPS system, we want to eliminate the conflict. We want to eliminate the conflict, or what we call the brawl, if you will, as demonstrated in this slide here. And this is a system that we have in place. As Rick mentioned, this is 30 years of trial and error and development, implementation, built, completed, and approved, 100% approval, by the way, plans, all executed using the same concepts and the technology that we simply highlighted here today. And if more users take this on, if more engineers, if more municipalities and planners take on this educational system and the software, we will begin to eliminate what's quite prevalent in this area, which is some of the flooding that we have due to the lack of attention given to the impervious, non-impervious surface, which here in Fargo, as we saw today, there's a huge disparity between the amount of pavement surface to actual residential surface that there is, residence rather, that there is here in the city of Fargo. It's a sea of pavement that we see when we're here in the city of Fargo. And that snow, that water has to go somewhere. When you're using a system that allows you to check for density, when it allows you to check for impervious surfaces, you can quantify the amount of impact that you're having environmentally to an area, particularly, again, to an area such as Fargo that's already hard hit. So when we look at the timeline land development process, we see a number of changes in productivity, hardware, cost, software, but there's no change in the subdividing efforts. When we look at technology changes for something as base as an automobile, 30 years ago, the Ferrari, which was top of the line, gets completely blown away by a base model car today. And that could be any car. We're here demonstrating the Camaro, but in every aspect, it outperforms it. Again, emphasizing, ladies and gentlemen, the advancements in technology, okay, that have progressively been moving forward. Where are we at as it relates to planning? Where are we at as it relates to technology used for planning and designing? This image that you see here is housing today. Actually, that's a cartoon 30 years ago. Actually, 60 years ago. But it looks just the same as some of the images that you're seeing today and some of the developments that exist today. Why, ladies and gentlemen, are we doing this? Why have we not advanced in the way that we approach planning and designing? So again, what we've emphasized with the performance planning system is the increase in space and density. We're reducing environmental economic impact, improve housing on all levels, of course, and we take in consideration the natural terrain. And all this is taught. All this is taught in the performance planning system, and the software system is the